Got it. All right. So we record these presentations, and they become a part of the lab archive. So we collect all of the presentations that made that week on a Google Drive. I record the session and then save it. And then those are all linked. In fact, once you get set up with GitHub, then you'll see the whole archive. And we've been doing that now for 6 years. So there's a pretty good record of everything that everybody's been doing. So it makes it kind of cool, projects kind of carry on from student to student over the years, and you can go back and you can see things. It's kind of it's been a good resource. All right, so I'll share my screen. Usually we have kind of a nice keywords in here, but I forgot to do that this week. I did. A friend of mine was prepping a slide and pointed me to Scholar Googler, which basically looks through your published work and creates a word cloud based on that super automatically. So you just put in your Google Scholar ID, and then it spits stuff out. So this was me. So LiDAR kind of at the center of it, but lots of other things showing up here as well. I've done a lot of work with tornado damage in the past, partnering with meteorologists. Photogrammetry, urban, perception, slope, visualization. I think this is a pretty good representation of the stuff that I do. I was pretty happy with it. I guess we'll do it that way. I got my Part 107 many years ago. You have to renew these things every 2 years with you used to have to actually retake the test. So I did that once. And then after that, the FAA created this online training. It's really quite good, more efficient and probably better at teaching you what you need to know than just retaking the exam again. You're just ad hoc studying whatever you come across. So I do really like this training. It's free. Anyway, I did that on the 4th of October, so it's good to be legal to fly again. Just a couple of days ago, DJI, who makes really great consumer drones, but also increasingly enterprise drones, released a new LiDAR unit. So this is actually a paired LiDAR with a camera. So you get a full, RGB point cloud. We are almost certainly going to buy this almost immediately. So this should be ready for flying probably in 1 month, 2, I guess, probably at the outside. It's the version 2 of this model. So the L1 has been out for a number of years. L2 is out now. Some really cool things about it. It's got a really good range on it. So, at least what we'd be flying at. So the maximum height that you can fly is about 122 meters. It should work quite well at that altitude. They're saying something like 2.5 square kilometers covered in a single flight. As a point of reference, we just flew an area in the Solomons and got about 2.5 kilometers squared in a week. So now we were imaging that quite intensely. So there is that. But in any case, I think this is going to substantially improve what we can image. We're also going to get a DJI M350, kind of their workhorse RTK drone. So excited about that. That should come soon. LiDAR visualization is super important to me. This is some work that's been kind of around now for, I don't know, maybe 10 years. But I ran across a news article actually came out. So that's the one here on the left. Dan Koh is the guy that did this. He was out of Washington. Washington has a notably strong cartography program, and among other things, in GIS and programming and other things as well. I think that he's not actually a geographer. I think that he might be a geoscientist by training, but plenty of geologists do LiDAR. What Dan kind of specialized in was developing visualizations and methods of highlighting where rivers used to be. So these are all sort of intended to bring out like the old meanders and oxbow lakes and other stuff that's around, highlighting the current channel, but also the historical channels. So some really cool work here. That's the news article. And then this is his own website, so dancocardo.com. And then, you know, specifically he's focusing on geology and natural hazards, but there's some really amazing LiDAR and 3D visualization stuff in here that I'm super excited about. Liam, you were in the GeoViz class, weren't you?
Yes.
Yeah. So we had a good section on LiDAR in that class. But the things that you can do with GeoViz and LiDAR are mind-blowing. Lots of really cool applications for this stuff. And a ton of it finds its way into archaeology, by the way. So archaeology, you know, it's not just the scanning, it's like making sense of the data. And a good visualization is going to help you do that. And these do an amazing job. This was a cool thing, we do a lot of photogrammetry work, which is building 3D models from images. Usually we're using things like a GoPro or a digital camera. This is a sensor that you can put in an old vintage camera, and it becomes a digital imager. For those of you still at Tech, there's that awesome old camera shop it's like a record shop and a camera shop. I wish I was still at Tech. If I could grab one of those cameras, I would certainly put one of these things in it and just see what you can do. There's a lot of really, I mean, each camera lenses are all different. It's kind of a cool project. One of the old lab members is Jack Gonzalez, and he was super into photography. So I was interested to see if he was into this as a way to resurrect old cameras. This one was cool. So this is Tinker RTK. So RTK GPS, RTK stands for real-time kinematic. It's a way in which you use a static stationary GPS to relay corrections to another nearby GPS to go from meters of accuracy to centimeters of accuracy. So for archaeology, you're often working on these sites that are pretty small. And so if you can get things mapped down to the centimeter instead of the meter. Now, archaeologists have other techniques to do this. They would use things like total stations. They would map things by hand. They have other ways to do it, but this is kind of a cool way to do it. We've been using in the lab RTK units for a long time. In fact, you'll see a slide. This is one of the RTK units that we have. We've got a smaller one that goes on a drone, but this is kind of a bigger one that goes on a big pole. These things are pretty expensive. This one that I just showed you is like $2,500. The one that I just bought for the lab that's smaller and goes on a drone is like $800. And that itself came out of a Kickstarter campaign. Like before that, like Trimble was selling this stuff for like many thousands of dollars plus the subscription costs. So you know, as other, you know, GPS geeks start to throw their hat in the ring, we're starting to get like the electronics are dirt cheap, right? Like there's nothing magic about this stuff. There's no reason it has to cost $800. Yeah. It's just like people are willing to pay it, so that's what that costs. But this is a cool Arduino project, basically. You know, that's probably, you know, I haven't priced this stuff out yet, but you should be able to build one of these things for like certainly less than $100 and probably more like 70. I don't know. So this would make a nice project. Shashank and Addison, did you know Addison? You probably knew Andrea Granger, right?
Mm-hmm.
Yeah, Shashank, did you know her?
Yeah, I think in our last semester it was my first semester.
Yeah. Okay. So she was an undergrad. She worked in the lab to help build drones and did Arduino projects. She was really super good with like technology. In fact, the drone that's just above Shashank's head, she and another student put together. Anyway, she was at Johanna Arredondo, who's a PhD student in the lab, just did her defense, which she passed with flying colors. Andrea Granger, who helped her with some of the field work, was at the was at the defense. So she and I chatted on Zoom on the side a little bit. So she's in a master's program, but I got to tell her about this. She's an Arduino girl, so she'd probably really enjoy this stuff. But I'd love to get the stuff and just like put it together and see if we can make it work. $800 is an okay price for RTK GPS, but I would love that to be a lot cheaper. I've been super interested in the iPhone 15 for a long time. There were rumors that the iPhone 15 was going to have a much upgraded LiDAR sensor. So the iPhones and iPads have had it since version 12. They're pretty handy. You can do a lot of good stuff with an iPhone LiDAR. The LiDAR actually sort of helps coordinate the image reconstruction, but it is quite helpful. So you're not really getting a LiDAR scan. You're sort of getting this like hybrid between LiDAR and photogrammetry. I had hoped that the iPhone 15 sensor was going to be 10 times better than what was on the 14, but that's not true. I've been following sort of Reddit threads as people buy these and take them apart and try to figure it out. Looks like it's not going to be great. So that's fine. It's probably not going to be a lot worse. I mean, you can see the differences in point density, but again, because you're not really doing a LiDAR scan, you're sort of using it to aid the camera reconstruction. It's probably fine. But anyway, it's not real LiDAR. It's sort of like helpful. So needless to say, I will not be buying a iPhone 15. This is a little bit dated, but this was in response to a conversation that we had at one of the build meetings. So the project that Shashank and Addison are working on uses indoor LiDAR sensors to reconstruct the environment. They're both trying to not map stuff, but to capture movement, the dynamic parts of a scene. The thing that I was thinking of where they were sort of breaking things, and I'm not 100% sure that this is right, because I think that there was one more thing that I found that they were doing this on, but I can't seem to lay my fingers on it. But anyway, they're taking a depth image, which is it could be a LiDAR, it could be something else, and then they apply a color map to that, and then they send it into Facebook's segment anything algorithm. And what they found is that it works pretty well. As I'm saying this, I really don't think that this is what I was thinking of, but anyway, good to sort of bring this back to mind. I ran across another LiDAR tracking software. So this is Veovo. I don't know anything about this, but because we're using Blickfeld LiDAR and then their software Percept to do the object tracking, this lets us, I'm just interested in sort of like keeping track of what other softwares can do that job. So Veovo can do it. I'm not particularly interested in it and for any other reason, but it's good to know. I was poking around with the Ouster LiDAR, and the Ouster LiDAR SDK 1 seems like it can do SLAM, so I'm excited about that. That instrument finally did get ordered, I think, and hopefully will arrive someday soon, either real soon or hopefully not later than 2 months. I should probably send a follow-up email to make sure everything's squared away there. But I did see that the Ouster SDK can do object tracking as well. We work with a lot of point clouds, and oftentimes we want to simplify those out. And so this is really just kind of a reference for me as I'm trying to keep track of software that can do this. There's, like the Percept software, there's 20 things that can take a point cloud and turn it into a mesh. It's not very easy to do well. And so, this software claims to do it really well. I have no idea, but I'd be interested in trying it out if it's free. We've had some problems with the indoor LiDAR system where we're sort of getting the times are mismatched on some of the LiDAR frames. And so it's sort of like a double exposure film where someone is here, but they're also over there. We just set the the LiDAR from NTP, which is a less precise protocol, millisecond level precision, to PTP, which is precise time protocol. And that gives us microsecond. I think that I had said nanosecond when we were talking with Tim, and even as I was saying that, I was like, that's probably not right. Microsecond is PTP's resolution. There was a call for papers from CAGIS, looking for papers about GIS and remote sensing and other things. The theme of this conference is climate smart GI science, mapping a sustainable future. It might be the kind of thing that your work would fit well with, because we're talking about sort of environmental things and we're talking about thermal mapping. That might be attractive. Oftentimes, I know CAGIS actually never really cares that anything fits in their theme. I kind of wish they would stop doing themes for that reason, because I think it just keeps people from attending. People that would ordinarily like to attend see the theme and go, well, I'm not doing anything related to climate, so I just won't go. I think that it doesn't it doesn't do what it's supposed to do. That's a minor detail. But I think we should maybe think about remote sensing for some of that work. One of the other grad students in the department is interested in doing some scanning with an iPhone of actually the preserve. So they're mounting it on a remote control car, and they're going to drive it around and see what they get. I'm interested to see how that comes out. But one of the things that I advised them was you probably want to collect some GCPs so that we can get stuff aligned a little bit better. So that's why I was kind of messing around with the RTK GPS on a pole. This particular RTK GPS is called an MLID Reach. I had bought the $800 little unit because I used to run a correction station off of my roof. So they're tiny. You put an antenna on your roof, and then it sends its corrections out over the internet. And that's what I did when I was in Virginia Tech. And it worked great. It was fantastic. But I was like, let's see if New York has anything. California, I had noted, had a free public RTK GPS system, so you can like tap into the state's system. And there are some. There's a international system of these called CORS. Well, CORS is the name of a continuous operating reference station. What's the name of the? They just changed their name. Anyway, there's an international one of these. There's sort of like a ad hoc citizens version of this. But the state ones are nice because they're funded. They tend to be a little bit more stable. They're not any better, but they are often more stable, which is nice. So anyway, I did find out that there is one of these in Binghamton, which is fantastic. So cors.dot.ny.gov. You sign up, it's free. I put my username and the lab password on the lab wiki. So anybody can use these. In fact, it's got a nice feature where it just like uses the closest station, which is cool. So you don't even have to like browse like, oh, I want to use this correction station or that correction station. It's like, oh, you're close to Binghamton, you'll use the Binghamton station. So that's cool. Less fiddling around with this stuff. And was able to take it outside and got a fix and everything worked great. So that's great news. And this is just a slide showing the configuration on the unit. When I was in the Solomons, so Liam, I did some work down in Solomon Islands. This was an archaeology project. And what they're trying to do is map old World War II battle sites. And one of the things that so we were using LiDAR, but one of the things that they were doing was trying to use a magnetometer on a drone to detect metal and to map that. We used a thing that was kind of like suspended from ropes, and then we used a LiDAR generated terrain surface to like fly the drone like above that LiDAR surface, and that worked out okay. But there's another way to do it, which we were thinking about while we were there. We're like, well, if you had a LiDAR rangefinder, which its only job is to say like, how far am I from that, which is actually what like an iPhone's LiDAR is for, right? It's actually not for mapping. People have been using it for that. It's for like auto focusing your camera and like figuring out how far away things are in the scene. But these things will just say, you can like say, well, drone, I want you to fly exactly 2 meters above the ground. And so the LiDAR sensor will allow that. You can just like in real time figure out where you are and then fly higher or lower. And that's like way more precise than you know, conventional GPS. So our problem, our LiDAR surface was good, so that would work. But the GPS wasn't an RTK GPS. So the GPS error is, you know, meters. And so the drone itself was kind of doing that a little bit. DJIs have things like optical flow. They can actually do some other stuff to determine their position. But this stuff is great. And so we found, Carl found somebody demoing this on LinkedIn, which is like a great way to exchange professional information. Like lots of people are posting about their cool stuff. I've found a lot of good LiDAR stuff that way. But here they're demoing the DJI M350, which is the one we're going to get, with an integrated laser altimeter, which we will almost certainly do. If they got that to work, then we'll get it to work. And these sensors are really not very expensive. It's probably $100 or $200, and then all of a sudden you can just fly. And then I think this is one of the last things earlier in the week. So there's a computer that sits in a closet that's at this building where we're doing the indoor LiDAR study, and it just went off. Part of it went offline. It wasn't seeing any of the sensors anymore. We occasionally have problems where, you know, one sensor goes out or whatever, and we need to fix it. But this was the first time that it's been like entirely unresponsive, and yeah, it was fascinating. We were lucky because it was a dual Ethernet card, so we could literally just plug the one cable into another cable. Tim Baird is the PI, the principal investigator on the project. He lives in the building, so he was able to duck down that morning and just sort of like plug it into the other side. So we got it back going. The only other thing that I had to do was set up PTP, the time protocol, on that side of the Ethernet card. But once I did that, then everything's working. We always present some goals. It's nice to look ahead and sort of see what you want to accomplish. And we often sort of, I think you'll probably see on Shashank and Addison's, like, talk about how you did meeting those goals from last week. So I don't have goals from a little while ago, but my goals in the next coming week, I met twice with the Solomon Islands archaeology team. And there's some cool stuff happening there. It looks like we're going to get about $100,000 to fund some work trying to see how best to use the drone LiDAR to do what we want to do. So a little bit of money to do a little bit of work, which is great. I got the abstract submitted for the indoor LiDAR work for one of the regional AAG conferences in Philly. That's at the end of the month, 28th of October, I think. So I got to get that presentation. Plus, I'm doing another guest lecture in geosciences about that work. So if you're interested, you could attend and sort of see what that stuff's all about. And then I need to work on my papers. One of the things that I'll send your way once it's out for reading, one of the master's students that just graduated half a year ago is Gunjan Barua, and he did the work on his whole master's thesis was about thermal modeling, thermal imaging with drones. Yeah. Yeah, that's due out. It could be out now. I'll probably check after the lab meeting and see. This close to being done. All right. So that's it for me. Liam, as we go through, I'll stop my share here. One of the things that they kind of take the form of presentations, but always chime in if you've got questions. Like, they're intended to be pretty open. One of the downsides of Zoom is that it makes it a little bit harder to chat. But please chat. The more you break in, the more normal it is. So I encourage you to do that. All right. So we'll turn things over to Shashank and Addison, I think. I still have, by the way, kind of a janky speaker. I got did I tell you guys about this? I ordered the lab a 65-inch touchscreen. That's going to be our new touchscreen. So it's up in my office right now. I probably don't have time to get it set up today, but next week we'll have something fun to play with. I'm hoping that's going to be really good for like LiDAR and 3D visualization to be able to sort of really interestingly interact with it. I don't know if this came out when I was teaching GeoVis, Liam, but the size of your map actually makes a big difference for how you experience it. So like, you're looking at something that's this big versus something that's 65 inches, and it's a whole different, it communicates differently. So that's why I wanted to kind of go big. We'll see if it works. All right, Shashank and Addison.
Let me go ahead and share mine. Oh, it's over there. Yeah, so I have a bunch of kind of like small pieces of stuff this week. So the first thing was ground truthing. I had this weird error happen when I was moving and like exporting the ground truth data set from my personal computer to Rooster. Basically, I want to have a copy on the lab computer. So when I was exporting this like date time field, and it's weird because I'm working in a shapefile, and I know ArcGIS shapefiles already don't really support time fields super well. But I had this really weird issue where when I exported the date time field, it got rid of the time after the date, and there was no way to get it back. So I had to basically go back to the first part, make a text version of the date version, switch it, export that, and then switch that text version back to a date version. So it was like this weird kind of workaround. I don't know why ArcGIS does that, but
yeah, it's a limitation in the shapefile. The shapefile format actually doesn't support a date time.
Yeah, I've had that problem too when like doing stuff in Python, and like I went to write out one of my, I think went to write out the percept data to a shapefile, and it was getting that. It might have been the collision data set, but went to write out one of those to shapefile, and it kind of was saying like, oh, shapefile doesn't support date fields, so I had to write it out as like a geo package and then kind of bring it in and switch it around.
Yeah.
So probably just like a similar sort of thing going on here.
We should probably be forcing ourselves to use geo packages, which is perfect. Like, the reason I haven't switched is because I find them still a little bit buggy. But shapefiles aren't great either. So I don't know. I'm glad to hear that you tried.
Yeah.
Ultimately, your experience is enough. You make your own decisions. I mean, and like I said, I still use shapefiles for stuff. I just, I wish geo packages were a little more reliable.
Yeah, I'm still using mostly shapefiles for pretty much everything. But the data set's now under stir, and it's like fully up to date, fully updated and everything. So there's currently, I have 36 ground truth collisions, I think, after yesterday. And I started making a new classification of ground truth collision, which is just what I'm calling an event. Because I was there for maybe 3 or 4 hours yesterday at the CID, and just like kind of doing some ground truthing and like catching up on some work and stuff, but like mostly kind of like focusing on getting like good ground truth data. And an event started happening in like one part of the building. And within that event, there were so many collisions to the point where like I wasn't going to be able to keep track of every single one.
Yeah.
So kind of what I did is I just made one point and called it an event. And then when I go to like look at that, I can kind of, and it might be a little bit more difficult to, ground truth everything accurately. But it's hard when you have these events and there's people bouncing back and forth to like even say, hey, what really is a collision in these like really big events? Because like, are they unplanned and are they spontaneous and like things like that? So just kind of have like a single data point and almost its own category. So then when I'm looking at the actual data itself, and there were 12 collisions within the span of 30 minutes there, I can compare that and say, I don't know if I picked out all 12 that like I had seen maybe, but I can at least say, hey, there was an event at this time. So expect a lot of collisions in this area at the same time, because I just don't know if it would be possible to like reasonably ground truth every collision that was happening as a result of that event.
Yeah. No, I think that's a great idea. I mean, even you can imagine there's a lot of applicability for like event detection, right? Like if I'm interested in LiDAR perception for security, like I may well be interested if like, you know, more than 10 people get together, right? Like, not to be like creepy authoritarian spying on people, but like, you know, like that's the kind of thing that people would want to know. You know, for our purposes, a little bit more benign, like, you know, separating those out from the collisions data set is important because they're a whole different thing.
Yes. So I'm thinking of like ways to do that in the algorithm and stuff. And one of them was being like, if there are X amount of collisions in a like close area happening within, 20, 30 minutes, you can just kind of you can almost take those collisions out and like put them in their own data set of like just event collisions. So then, because I think otherwise the events would almost dominate any sort of like normal pattern.
Yeah.
So it will be useful regardless to kind of isolate those and like figure out ways to kind of almost take them out.
Yeah.
Or at least kind of signify them as being different.
So taking them out so the data doesn't get skewed, kind of thing.
Yeah. So that, yeah, if he's talking about what happens with collisions, he's not just actually talking about what happens with events, because 95% of collisions happen within an event.
Yeah.
But that's not what he's interested in. Is that right?
Yeah, that's pretty much what I was. Yeah, pretty much exactly that. Because I was there for again like 3 hours yesterday. I had maybe 3 or 4 kind of like more, maybe 4 or 5, but like a couple like natural collisions of like weren't connected to the event. Like 2 people just kind of happened to run into each other in the space, and like that's really good. Because that's the stuff I'm like really most kind of focused on. And then within about a span of like 4 or 5 minutes of this like event starting, it was more than 4 or 5 collisions for like the 2 or 3 hours I'd already been there. So I think that the events will just like dominate everything.
Yeah. Cool. Yeah, good thinking.
And I kind of touched on this on I think either Wednesday or even last week sometime. But there was this Battersby article that Dr. Pringle recommended that I read, and it was kind of looking at generating network paths from like high movement data. So this data was basically like a collection of points, pretty similar to the way that Percept can basically report out data. And there were a couple cool tools that are in this like ArcGIS geoanalytics processing, and I still need to shoot an email to Seth and ask about that. But it's like its own kind of thing separate from ArcGIS Pro to what I understand. But there are like 2 really cool tools that are like designed to show one, this like find dwell locations. So you can find where like individual units, like where people are pausing within their like movement with their lifetime. Which I think would be interesting, because then you could kind of see specifically here's where these like conduits of movement are happening. And then seeing is there correlation between the location of collisions and the locations of these like dwell locations. So I think that's pretty interesting tool that I might try to spend some more time looking into. And then the other one was also called Reconstruct Tracks, which is doing pretty similar to what I've been doing in Moving Pandas, which is like a Python way of doing a similar thing. But if you have a collection of points with a time data set, this Reconstruct Tracks can kind of keep this almost trajectory format, which is what Moving Pandas was calling it. So that individual vertices are kept in the line feature basically, which is not something that like normal ArcGIS supports with like a simple like line feature.
Did you get a sense of, did you talk to Seth as like whether we have access to GeoAnalytics Engine?
No, I still need to shoot him an email and ask. And then a little bit of just like looking at collision stuff on a larger data set. So I just want to test out kind of like the effectiveness of the algorithm on like a really large scale, and just kind of not necessarily to see like how well it's doing necessarily, but just to see like how well it can run a large set of data, and then like how many collisions it's really spitting out for a lot of days. So I took, I guess, 2,000 percep files. So this was about 12 days of data. So I was grouping them by this, like, basically by the file name because it's the easiest way to do it. So all the percep data files are put out with like this. Is this the seconds since?
Yeah.
Okay. So it's all based on like the number of seconds since a time in 1970 or whatever. But using like basically 4 digits. So the 1695 lasts for about 12 days, and then it would go to 1696, and then that would last for 12 days, and then 1697. So I kind of just grouped it by one of those. So basically 12 days of data. And then the 169 would then cover around 120 days of data. Which is just kind of an easier way of like, rather than running it on everything, it's just kind of like a super simple way to group the data that way. But I've been encountering lots of problems when doing this. So the first one was that this path not found in Axis. And when we met on Wednesday and talked about this, Shashank kind of said that it might have had something to do with the fact the files were empty. And I ended up checking, and it was because the files were empty. So there were, I want to say 100 or so files that basically if there was nothing in it, it couldn't read the data, and then it would return this like error, but it wasn't really specifying that the error was because the file was empty. But I think that every empty file is 155 kilobytes, and then that's kind of like the size of like the empty JSON that like records at this time there was, and then it will say like 0 objects, obviously. So basically I used the file size to remove the empty files. So using, I think it's like OS, I think is the name of the package. But I think it was probably the easiest method to like take out empty files. So it took me from around 10,200, I think, to 9,100.
That's kind of an interesting statistic. That's like 10% of our times have no activity.
That is an interesting thing, like on its own, actually. I didn't really think
Yeah.
about it. Provided that they all are, the ones that are empty have that exact data size. But even after doing that, I've been encountering an issue. I didn't grab a screenshot because I was I accidentally closed out of the notebook before I grabbed my screenshots. But I was asking ChatGPT about it, and it was saying that it was probably something along the lines of being due to like an unexpected or unsupported character in one of the JSON files. And like Googling and Stack Overflow and stuff, I've like found similar things, but most of the solutions that I found so far have been like take out the unsupported character. Which
I
is
think
like,
I've run into this problem.
you've had this deal, okay.
So I think how I solved it like was one of the JSON files had like a space character in the like in the starting of the JSON file. A space. And when I removed that, it started working. But I don't know if that's the case.
It might be, and it's just like, it's one of those I might have to figure out which file it is, which
Yeah,
is like,
that's going to
that's
be-
gonna be the problem.
Like when
So maybe count for like each one and just like have it print file blank is good, file blank is good, and then when it gets an error, it'll tell me.
that's what I was thinking, like a try catch statement where you try to read everything, and if it cannot read it, it will just display the file name and you can look at it.
If you do figure this stuff out, Addison, let me know. I mean, one of the things that we can do is modify the build tools package so that it's handling an empty file properly, right? Like that's probably an adjustment that we can make, because what it probably should do is just return like a data frame that has all of the headers but no data, right? And then the merge operation would probably just happen normally. I'll put it on my to-do list. I can't promise I'm gonna get there soon, but
Yeah, I'll try to find a way to get past this like unexpected character. It might also be like a space that I accidentally added myself or something in one of the files. Just while like looking at them and inspecting them, I might have accidentally pressed a key.
Yeah. Yeah, but be thinking about like maybe we need to make an improvement to build tools, right? Like, you don't, once you figure it out, we can just make it better.
So then the kind of last thing I wanted to do was talk about the sensor troubleshooting. So Shashank and I met at the CID on Monday for a couple hours. So Shashank had gotten an Ethernet cable from Les, and then we had it after the CID. So this sensor here, basically, when it's plugged into this blue wire, it's not giving any sort of like data. So the sensor itself can be powered, but then the data itself isn't transmitting to the like closet and then to the computer. So it's like we can't actually access the sensor even though it's powered on. So we had grabbed a different Ethernet cable, which is this big one right here. I basically bypassed the blue sensor in the ceiling and just went directly from this box, like as you can see, it goes up and then into the ceiling up here. And that ended up letting us connect, which kind of made us think that there's some sort of issue with the cable. So then what we did is like sent a couple emails. So I guess sent an email to people at NINS, which is like network services. And then this morning, which I haven't had time to obviously update the slides yet, but I do have information. So we met with Shashank and then obviously Dr. Baird and then 2 people from NINS actually. And like just to like discuss kind of what could be wrong and like test some stuff. So we tested some stuff in the closet and everything there was good. And then we tested the like patch box with 8 ports in the ceiling, and that one was good. And then when we tested this, so we tested the other end of this blue cable, or I guess we tested the port that this blue cable was plugged into on the other side, in the ceiling up here, and that was good. But then when they like cable mapped to this blue cable here, it got that like it was connected, but device was not powered on, which wouldn't make sense because it should be that like basically everything should have been powered on because everything that like we had tested on the way to that final step had been powered on and working.
Yep.
So it was like it was working in the closet, it was working in the ceiling, and then it's not working here on this last step.
Yeah.
Which then like finally led them to believe that it was a cable issue. They were a little stubborn and hesitant to admit that there was an issue with the cable, which is kind of what we tried to tell them like 4 or 5 times. And we were like, yeah, we tested literally everything. Like I can guarantee you that it's the cable. We tried it with a different cable. It works. And like, so what they did is they tried re-terminating the cable. So basically cutting off the ports, like cutting off the little ends and then putting in ports.
Yeah.
And when they did that, the cable that was, or like that blue cable in the ceiling was working. So it was an issue with one of those 2 ports where like it was able to supply power, but not able to transmit data.
Yeah. Cool. Yay.
Yeah. So finally that problem is fixed.
Part about it was like when they left, he said, "See, the cable is working."
The cable's working. Yeah, but it wasn't. Okay. It's okay. We're all good.
That took a month.
Yes. It took a very long time to troubleshoot everything. So it was glad that we got everything figured out.
Well, I'm glad that it's working.
Yeah. So that's all I have for this week. My goals for next week are I want to figure out how to test that collision data set on like a smaller subset of data. So a couple weeks, a month, something like that. And just kind of see how long it takes to run, how long it takes to process, and then like seeing how many collisions I'm getting for a couple weeks of data.
Yeah.
And I also want to like, once I do that, I can kind of see, is there a relationship between like events and collisions and like how many collisions happen as a result of like these events, and seeing like how much that skews the data. So looking at that sort of stuff too.
Cool. Very nice.
Stop sharing. I guess we could switch tabs, but that's all I use there.
Addison, as you're kind of moving ahead with that, be thinking of like, you know, as you're giving your talk about collisions, how would you want to visualize a collision? I've got Did I ever show you the tweets about weather that I did?
Maybe.
Maybe. Shashank, can I share my screen actually real quick?
But I might need you to jog my memory on it really quick.
Yeah, let me see if I can find it real fast. It's on YouTube. That makes it a little easier to find. All right, so what this was is I found I used Twitter to find out who was tweeting about weather, look for all these weather related terms. And then
Yeah.
when they did, the visualization that I picked is there's like a circle and then it kind of expands but fades out. And the metaphor is like dropping a pebble in the water and sort of this like event, it's ephemeral, it lasts for a while, and then it goes away. I'm not saying you have to do this, but like think about like as you're trying to explain to somebody like about what this is, you know, I could imagine having like the raw. You guys haven't seen the data for. Let's see if we can do this. Go back.
That's a really cool visualization.
Thanks. Yeah, it's I like this one because it's like shows you know, it's overlaid with the weather information. So you can see like the fronts moving through and what people say. And then it's got like the daylight and nighttime, so then you can factor out like, oh, it was, you know, 5 in the morning. The other one that I wanted to show is, see if we can find this actually this way. Got too many things with that title. So this is all 11 LiDAR sensors fused together, and then you can see like people moving through the system. So this is like super accelerated, right? Like, I don't know. Did we ever figure out how fast this is going? Well, faster than 30x probably. Maybe it is 30x, I guess. But when there's a collision, you know, I could imagine, Addison, like this being sort of like the foundation, right? Except played at a much slower speed.
Yes, that's kind of what I was thinking.
And then when people come together, you know, some kind of marker indicates that this is a collision, sort of along the same lines as like, you know, Shashank has been doing, trying to like compare things. You could maybe do it in ARC, and you could use the NetCDF as the basis. And anyway, you'll figure it out. But like, be thinking about ways that you might want to visualize a collision.
Definitely.
Okay, I think we're ready for Shashank. Oh yeah, happy Friday the 13th.
So over the last 2 weeks, I've been working on a bunch of things, like just doing too many different things, I think. So the first thing I wanted to mention was we were trying to fix the cube that was not working, and just to take note of this. This is the 102 sensor that was not working. This is 114 and this is 113. We confirmed it today by looking at different viewers and seeing the LiDAR stream. So what we did last week was we took a direct cable from 102 to the port box right up here, and just started the transmission of the data that we were not getting. We also checked the port box for all the ports, and only one was not working. That was the third port. I don't think we'll be needing it. We didn't say anything about it even today. But when the NINS people came, they probably did something called retermination of the cable, where they just took out the ends of it, and we have data now. We have data from 102, so we'll probably have to look at the data we are getting and maybe fix the orientation of the cube. That's probably what we're doing next, and
Yeah.
trying to add the data to the stream we had. So I'm very glad that we got this done. And I'm glad that we pointed out the cable was wrong and we were pretty confident in it. The other thing I was doing was Dr. Bingle added a new parameter to the points to multi-points function. But like when I was trying to run it directly, for some reason, if I directly import it from build tools, it does not work. It gives me this error. It's pose.position.x. When I was going through it, it kind of says that the thing that you are trying to get, pose.position.x, does not exist, and that should not be the case because in the database I can literally see it, it's right there. So I just have to do a local definition of it, and the same function works. I don't know if I'm doing a wrong thing when I'm re-updating it, but I don't know. I feel like I've done that multiple times, and
Yeah, I'll try to take a look.
that's something I wanted to do. So the test time offset parameter is basically a new thing that's defaulted at 0, but you can basically update this parameter to make the data I read this time at a simple offset in time. So my thing that I was trying to do was I was trying to check if I could test this time parameter so that the percept points and the animations we record kind of align. As you see right now, this is as at a time offset of 0, and the point right here is being detected using this chunk of point cloud, but it's not as aligned as we'd want it to be. It's suffering from a small delay. Even this one, I think, is suffering from the same. So this was what I was trying to do. I was trying to check the time offset. Even though I'm just including screenshots, this was a very, very rigorous process. I'd have to write out the shape files, bring it in ArcGIS, and ArcGIS does not like the time field, and I'd have to take it out as a text file, read it in, so it's a bunch of messy stuff. So this is the 0 time offset. When I set the time offset to 0.25, there is a significant change and it gets much closer. So if I just look at this point, it gets much closer to it. So 0.25 was a good number. So I thought if I kept on increasing it, I'd get better results. So here is 0.5. To my surprise, 0.5 gives me the exact point as 0. I don't know what's going on here. And when I'm trying 0.75, it's literally the same thing. So
What?
0.5 worked. And I don't know if the time offset takes an input of decimal seconds.
It should.
I don't know if I'm doing something wrong. 0.25,
Absolutely should.
0.75, and then I have 0. Then I have 1. So 1 and 0.25 give me the same.
Oh, that's weird.
Yeah. So I'm not sure if I'm.
Is that true elsewhere in the scene as well? Like, I guess I'm only paying attention to that one, but is that true in other parts of the image too? Or is that the only moving object really?
So let's look at this again. So 0 and 0.25.
Yeah,
So I'm just
yeah. Everywhere it's the same. Yeah.
the most apparent one. So I'm just looking at those two. So 0.5, 0.5 goes back, and then 0.75. I was very skeptical about this. I thinking that I had done something wrong, so I did this twice. So this is my results from the second time, and I got the same thing. So I'm pretty confident in I'm not doing something wrong. And I even tried the negative time offsets, but I'm not included at here. So 0.25 and 1 gave me the same result, while 0.5 and 0.75 did not do anything with data. So I'm not sure what's going on here, but this was a very good experiment. I think altering the time offset will give what we want. I just need to figure out what's going on with different time offsets. But this was a very fun experiment.
Yeah, that's interesting.
Yeah. So that was one thing. The other thing I wanted to do was compare how the LiDAR data is for PTP versus NTP. So we had data from NTP, so I started annotating it. I just selected 5 very busy random minutes of random days, and I'm just logging it, annotating it, and I'm trying to also run all the methods of computer vision as well as deep learning. I've tried so far for both NTP and PTP to test like what the differences are. So I've got almost everything ready for the NTP side. For the PTP side, we have data running now, right, Dr. Pringle, from yesterday.
Yep.
So I'll probably select like 5 minutes of the PTP time period and then do the same thing for that. So this is something I've been preparing up for. Okay, so let's see if this gives me what I want to see. So the other thing I was comparing was I was trying to see if using the two variables we are recording, one is the maximum returns and the other one is the intensity returns. And I was trying to compare if my methods that I was trying for object detection is running better for one or the other. I'm not sure if I can like see major differences. It kind of looks almost the same to me.
What is
So this one is the DSM and this one is the intensity on the right one.
yeah, and what are you using to do the detection on this one?
This is the background subtraction method. I have the results for like almost everything.
Yeah.
And I'm also trying to see if like one method is better for like one input.
I think I mean this is good. So we're not really seeing significant differences here. Pretty similar performance, I agree. You could, you know,
I was thinking
measure it and get a sense of it, but yeah, I would say probably the same. I think probably you're gonna see some big differences if you're trying to use like the deep learning based methods,
yeah,
more like frame based.
some minor differences are seen, like the thumbnail you are seeing right now.
Oh yeah,
In this one, like you can actually see that DSM has like a better recognition of one object at least.
that's great. And even demonstrating, I mean, even to that point, demonstrating that they're different is great, right? Like that's an important thing to know. Cool.
I was thinking like just looking at it visually might not be the best approach because I either need to sync it to like play. So I'll probably stick both of these video in like a bigger video.
Yeah.
Like intensity. So that's something I want to work on again.
And then like slow it down maybe.
Yeah, slowing it down and like if I play
Start
with
to see it the fast.
yeah, and I think like making it the same video will give us a better. So this I did the same thing with the frame differencing, and I think with the frame differencing, I see some like more changes than the background subtraction one. That's still too fast to see changes, but I feel like background subtraction didn't have a significant change, but for frame differencing, I'm detecting more objects for the DSM one.
Okay.
So this is.
Shashank, be thinking about, you know, putting as much of this stuff as you can into the thesis. The danger for you right now is to do work that doesn't wind up in the thesis, and this is great. Just spend a couple of hours to try to write up what you can.
That's something that's in my goals for today.
Yeah.
Write about everything I'm doing. So the main shift algorithm, I've not been able to make it work. Surprisingly, both of the methods are like showing only one box. I'm thinking my algorithm is not working at all. So
Something's broken, yeah.
this is so funny. Yeah, so
I think
this
there's something there.
is the second major thing, a ghost problem. This is the second major thing I want to work on. The other thing was like I'm because the DSM and the intensity were majorly meant for the deep learning tool. I tried to run the deep learning again for the DSM, not for the DSM, but the intensity one, so that I have like the same data of 5 minutes for both DSM and intensity. But like when I ran this, it got interrupted for some reason, and I haven't had the chance to run it yet. So this is something that I've been looking really forward to. I think this will show some significant changes because I can see that visually the DSM and the intensity are very different.
Yeah.
So goals for next week, I want to work on the deep learning model. I think that's the major thing I want to work on. The other thing was like when I was comparing the other methods, background subtraction, frame differencing, I was sensing that I cannot compare it visually. So I was thinking of exporting the points out and doing a metric test with the annotations. And I have to fix the mean shift algorithm, and the major thing is write about everything that I've been doing so far.
Add a goal for both of you actually, which is that we need to schedule a committee meeting for both of you, because I think it's good to keep, you know, Todd and Nicole updated on what's going on. I know as a community member, I always like seeing things, not like every week or anything, but like certainly every semester, and probably twice a semester is a good number to just sort of like, here's where we are, and then you know, when the thesis comes around, they're not just like, what is this? Maybe try to send an email out Monday, I think would be fine. You don't have to do it today.
Sounds good.
All right, thanks, guys. Peter, you want to talk about your work? All right, let me see if I can. Is it easier if you just join? Maybe I didn't think of that, but I suppose you could just join the meeting. Present like Addison's been doing.
If I did send it to your email, so that
Okay, I'll take a look there too. Liam, how are you doing? Any questions? I know that on your first day, it can be a lot of weird stuff coming by.
No, I think I'm doing okay. I think I got the gist of most of it.
Cool. I just got a new phone yesterday, and I'm like in between phones, so I'm not sure where my two-factor authentication is going to go. You send to which one? You send to the Binghamton one?
I should. It's okay. I mean, what's the meeting ID?
It's yeah. Let me get that. If you type it into the web browser, that's what I always use. tinyurl.com/Telomere2. Yep. Okay, and don't forget to turn your mic off.
It's so weird.
All right, should be able to share it now. Speakers off too.
Should be, right?
You get the mic off, but we got the speakers.
Like just like or the speakers on the way.
Yeah.
That was one that- This? I wanted that. We probably have like.
How about that? That's better. Get an echo.
It's-
Yeah. Yes.
Using is that about.
This one. I'm just like to find out, right?
And Liam, while you're here, our the work in the lab kind of varies a good deal. So you know, today you've heard a lot of different things, oftentimes more drone and exterior LiDAR is often a big part of it. So if not everything seems like it bears on what you're interested in, hang tight. I know the Solomon stuff that I'm working on now well.
Yeah.
So, yeah, hopefully I'll have a little bit more on that next week.
Yeah, I started taking a look at some of the papers from the person you knew from Michigan State. Was it Raidmaker?
Yeah,
Or yeah, so I started looking
Matt
at some of
Maker?
yes, I started looking at some of his papers, and those were pretty interesting. Though I could only really read kind of the abstract because Virginia Tech didn't have access to those papers, and
Oh,
I
okay.
couldn't pay for them. But they seemed pretty interesting.
I think that there are some ways to get a hold of papers without paying for them.
Yeah, I was thinking I was kind of doing it last night and then before I went to bed, so I'll look more into it today and this weekend.
Sure. All right. All right. Floor is yours.
That. This is zero. All right, so this was the article that Dr. Pingle sent me to take a look at. It's comparing the usefulness of 2D and 3D representations of urban planning. So
I think you're gonna have to advance over there.
I've had this one before as well.
Oh, really?
Yeah, it's just strange. All right, so the purpose of this study was to examine the preferences of urban planning professionals with respect to 2D and 3D visualizations. So kind of the driving concepts behind it were that static 3D visualizations are moving more into the digital realm, affording greater flexibility in rendering models. The GIS-based learning of urban models are being used more extensively for decision making, especially in policy making. And the 3D view is more useful for tasks that require an understanding of the general shape of 3D objects. 2D models seem to appeal more to just simplicity's sake. You can add a little bit of detail into those, like the study goes over that and how sometimes that detail is more effective in certain instances as well. But the types of research questions they wanted to look at was how useful are 2D and 3D visualizations in helping a planner to create a mental image of a proposal? What is the perceived usefulness of 2D and 3D visualizations when taking specified planning tasks? And what preferences do planners have regarding shadow representations, form, and transparency? So the study area and the methodology for this study was that there is roughly about a 1 acre section of land in Queenstown, New Zealand. They created a pseudo 3D visualization to gain an overall impression of the impact on the site. They built terrain using LiDAR data. Building heights were calculated based on enhanced LiDAR data, and the proposed building was digitized using CAD data. And Python was used for generating sun positions and helping with shadow perceptions. They determined qualitative and quantitative research data from a survey. The survey only included roughly 8 people in total, with 4 from the QLDC and 4 from the Lakes environmental departments. They only had 3 total interviews, 2 of which were from QLDC and 1 was from the Lakes environmental. The questionnaire evaluated the ability to imagine the proposal site, improve mental images of the proposal site, usefulness toward planning tasks, and preferences regarding shadow representation and transparency.
So they're trying to build this big. Where are my crayons? That's fine. All right, so on the right-hand image, I'm kind of moving my mouse, which probably isn't visible here, but the they're trying to build a big building in the center here, and the kind of bluish grayish stuff that's like shadows,
Yeah.
simulated shadows. Okay. All right, cool.
So the results from the study was that the 3D visualization was ranked fair for like processing like the mental images and looking at it from a different perspective. The 2D materials were ranked fair for helping the image as well and building of its surroundings. and 2D materials were preferred for measurement-based tasks. 3D visualizations were more preferred for complex assessment tasks, like whether or not you needed to see like the complete 3D representation of the object, or if it would be better for visualization purposes in general. And the participants preferred 40% transparency levels for shadows. They overwhelmingly preferred the volumetric shadows as opposed to the ground drape shadows. And the PP stands for the QLDC Planning Department, and the CP stands for the Lakes Environmental Consent Planning's Department. And you can see kind of the results from the images on the right-hand side too. So yeah, that's
Perfect,
what I
cool.
got.
Can you go back one slide?
Yeah.
So one of the things that I always find really interesting about studies like this, so this was, what year was this? 2014?
It was 2013 to 2014. Yeah.
Okay, it's published in KJSN. Okay, so 10 years ago or so, I worked with, so Grant Herbert was a master's student at NIU when I was there, and Zhuwei Chen was a professor there. This is kind of a classic kind of user study in geovisualization. We think we might do it this way. We think we might do it this other way. Let's try it and ask people and do some studies and try to figure out which one of these works better. One of the things about this, the reason I wanted you to take a look at it was, Gunjan, whose paper is just coming out in that very same journal, his work was sort of like 2D representations of thermal data collected from LiDAR and a bunch of stuff. And Lindsay, who was an undergrad, worked really hard at like getting 3D thermal representations done. And so the next big phase of the project was kind of intended to be, all right, now what about 3D thermal representations in a situation like this? Like, is it valuable? So one of the things as I look at this is, Liam, you took GeoVis, and in fact, I think Shashank and Addison both took GeoVis with me. You guys made these, right? You took LiDAR data and you extruded building footprints and you did something that looks like this. And while this sort of does give I like this term, a pseudo 3D visualization, it gives some impression of what the landscape is like, but it's limited, right? We're super blocky buildings, and it's not super realistic, right?
Yeah.
Like you can kind of imagine it, but it looks dated now. Like as I'm looking at this, I'm like, ooh, that doesn't. So, you've got to sort of extract what usefulness you can out of a study like this that's 10 years old, but maybe isn't as, so what lessons can you glean from this, right? Like, in particular, what I think we need to think about is like, okay, we're gonna stop this. Oh, can you stop the screen share thing? What does, if we can do 3D visualization, so I had, I'll do the screen share again because Liam hasn't seen this. The other two guys have, but, and I showed you, Peter, last week. Some of the work that Lindsay and I did.
Yeah.
This is a way to create fully 3D objects with cameras, using NeRFs. I want to log in here. Where's my login? So this is a thermal 3D reconstruction of a building, right? So taking a thermal camera and reconstructing the whole building, and you can see parts of the building hot, part of it colder. You were looking at 3D thermal reconstruction of an exterior space for these deer populations and other things that you're looking for. So the question I have that's kind of a more of a general question in here, let's. No, it takes forever. All Sorry, I want to load this 3D view real quick. At least I'm hoping it's the 3D view, otherwise we waited a long time. Okay, so try to ignore a little bit about the messiness of the reconstruction, right? There's stuff that we can do to improve that. In fact, let's go back and look at a good reconstruction. So thermal reconstructions are harder. Reconstructions from RGB cameras are relatively easier. The question I have is, what's the benefit of 3D over 2D, right? Is 3D really better? And if it's better, for what? Like, people always like them. An easy thing that we can say is like, it improves engagement. People are interested. People like to fiddle around with the 3D view. They're engaging, which I think is a good sign. What else do they do? Like, do they really help you understand the scene better than a map? So in this case, they were talking about like volumetric renderings of shadows, right? Like, we're thinking about putting this giant building up here. Here's what that's going to do for how much light your building is going to get. This is a 3D reconstruction actually from Google data. So it's a little lumpy. So it's still not great. But you can imagine this being better, right? Like, this is already pretty good, and it's better in a lot of ways than those blocky images that we saw. Imagine this is like relatively perfect. In fact, here, let's just, when I go to the source. Right, we don't have to settle for those extruded buildings anymore, right? We've got this. And we can take a much better rendering of that new building and delete what's ever in here and then add that new building in. That's what we would call like a qualitative difference, right? Like, it's not just like a little better or a little sharper. It's like, this is a whole different kind of 3D, right? Like textured buildings and like with real features, not down to every last detail, but lots of details. So maybe a matter of discussion with everybody. Why would this be better for urban planning? Or would it? Or would it just be, would it be cooler and more interesting and more engaging maybe, but would it actually help urban planning in a useful way?
I think, personally, I think it would, because it gives like an idea of, like, it gives a better idea of how far apart each object is, especially because like when like doing like a 2D view, you can only really like use a ruler and be like, oh, that's like 20 feet away from this other building. But here, like, your mind can actually like visualize like how far each bit is away instead of just.
Other thoughts, Liam? What do you think?
I think, I mean, I really enjoy looking at the 3D models. I think specifically because it definitely lets you see the height. Like, if I'm looking right here at the library tower, then it doesn't really look like anything special. But if you just change the angle a little bit, you can see just how much it really stands above everything else.
Yeah.
As far as like urban planning goes, I think one of the things that really stuck out to me in the paper that Peter just presented was, I guess, the shadows. So if you're planning on building anything near or around like parks or green space, then seeing the footprint, the vertical footprint of a building would really impact like things like sunlight or like quality of what you would expect maybe the green space would be like. So that's something that I just kind of thought about.
Yeah.
Looks like it's dying from this.
Looks like it's dying.
Yeah.
Yeah. The time of year that you collect this imagery is actually really impactful. One of the things that's going on here is, so this is downtown. Is this Johnson City or is this Binghamton proper? Do you know?
If it's near the Oakdale Mall, then it's Johnson City.
So this is Johnson City. I don't know where the Oakdale Mall is. One of these.
So that might be.
So these are, you know, less striking. I mean, I think when you're in places where like there's a vertical profile that's pretty different, like you keyed in Liam on like the tower, right? Where like these things are really different from one another in a way that's like hard to get a sense of. Whereas in this area, you're taking at like 1, 2, 3-story buildings. You know, features like this are pretty distinct. And then you get downtown. So this is downtown Binghamton, and then that's, you know, there we're talking about pretty big differences, right? Like you get a ton of value from a 3D view when things are different. Whereas like, I don't know, you go to like housing development or something, like here you've got some terrain differences that actually are pretty significant, right? So that helps a lot. So I find the 3D view very, very useful here. I'll show you this when we get off the call, but you guys have all seen like the 3D printed things. I would really like to make a 3D printed model of like the Binghamton downtown. Because I found that even like the digital version of a 3D representation is different than like the physical representation of a 3D thing. So those are the kinds of things also that I'm super interested in. So that was part of the motivation, was 2D, 3D,
Yeah.
you know, hopefully with LiDAR, with photogrammetry, that's what gives us the 3D. And then the question is, what's the value?
Yeah.
Very good. All right. Cool. Well, I think we'll wrap things up. Liam, you didn't have anything prepared, right? I didn't ask you to, so there's no, okay. So we'll wrap things up there, but thanks everybody for attending, and we'll see you back next week. Liam, I'll be in touch over email.
Okay, awesome. Thank you.
All right. Bye everybody.
Have a nice weekend.
Bye.